Deoxyribonucleic acid, quite a mouthful, but many people just know it as 3 letters, DNA. These molecules carry the code for every living organism, but now also have a growing number of applications in the field of modern healthcare. Here to take on the subject with me is Dr. Darren Green, dietitian Naazneen Khan, and Dr. Lauren Watson from the UCT Department of Human Genetics. Welcome to Doctor's Orders.
Thanks, Mike.
But before we get stuck into the discussion, let's take a look at what DNA actually is.
DNA, or deoxyribonucleic acid, is the hereditary material in humans and almost all other organisms. The information in DNA is stored as a code made up of 4 chemical bases. The order or sequence of these bases determines the information available for building and maintaining an organism, similar to the way in which letters of the alphabet appear in a certain order to form words or sentences. Within cells, DNA is organized into long structures called chromosomes. When a new life is created, half of a child's chromosomes come from the mother and the other half from the father to make up 46 chromosomes per cell. DNA has been researched since 1869 and continues to amaze and interest scientists and medical professionals alike to this day.
Lauren, what are the common applications for genetics in healthcare? What research are you involved in?
So UCT's Division of Human Genetics is involved in a number of different research projects. So we look at everything from cancer to inherited blindness. And what we're mainly focused on is what genetic changes might underlie either your predisposition to disease or might result in you getting a particular genetic disease. And also genetic changes that might elicit adverse drug reactions or influence the way in which your body processes particular drugs. Now I'm involved in stem cell research as well. So we look at how neurodegenerative diseases progress and what particular factors cause the cells in your brain to actually degenerate and die.
It's a very controversial topic, so we're definitely going to discuss that a little bit more. Naazneen, in terms of nutrition, how does that relate to genetics?
It's really about how nutrients interact with your genes and your DNA to be able to exert some kind of outcome. Yes. And we call this field of science or nutrition, nutrigenomics. And really, for example, you and your wife following a specific one of these fad diets, let's use one of these high protein diets, for example, and you go to the doctor and both of you get screened for cholesterol, and your cholesterol level is 7.6 and hers is 4.3. So what you could eat will have a different outcome on your numbers, whereas your wife could have a completely different set of numbers. And this is the science of nutrigenomics.
Now, what practical implications, what have they practically found out?
So you can actually find out whether you're predisposed to diabetes, yes, and then start eating preventatively, which we all should be doing anyways. Yes. You can find out if you have any kind of tendency towards a specific cancer and take the precautions accordingly. You can find out if you have any kind of diseases down the line that you can actually halt or start fixing right up front.
And that's where genetic counseling comes in.
Absolutely.
Then what is genetic counseling?
Well, we use genetic counseling to basically educate people regarding the risk of transferring genetic predisposition to generations to come. Food allergies, for example, and often you find people with sensitivities to certain foods can run in the family, diseases like celiacs, for example, as well. But on the other side, even things like normal allergies to pollen and to house dust mite. You find that if you've had snot sick day in a family and allergic rhinitis, it often is transferred, and diseases like asthma, which are also quite prominent, are certainly becoming more and more evident that there is a genetic predisposition in families.
So what are the main reasons why people should get genetic counseling, and when do they do it?
The main reason would probably be if you have got a family history that you know of a particular condition, so for instance cancer or cystic fibrosis, haemophilia. And the time to do it would be depending on whether you know your disease status or not. You may want to have a test done to determine whether you're going to develop the disease. Or when you're pregnant or thinking about starting a family, you may want to consider genetic counseling to help you understand what the risks are of passing that disease on to your children.
Genetic counseling is surprisingly accessible here in South Africa. We went to take a look at what happens at a local genetic counseling clinic.
Genetic counseling is a process to help people understand and adapt to the medical, psychological and familial implications to the genetic contribution of disease. The most important way of assessing risk for a genetic condition is by assessing the family history. Before pregnancy or during a pregnancy, a couple can consider their options in terms of testing. This might be carrier testing before pregnancy to assess the risk of the couple, knowing whether the mother and the father are carriers, for example, a recessive condition. There's new testing available very early in the pregnancy where you test the fetus's DNA in the maternal bloodstream. So blood is sent to the States and a lab looks at the fetus's DNA, and it's a more direct test for Down syndrome than previous testing, but it still acts as a screening test. The testing would depend on the risk that has been assessed, but could be chromosomal testing or direct genetic testing.
Now, genetic treatments aren't without its controversies. I've heard of designer babies. What's that all about?
So designer babies refers to when you are selecting for a particular trait or against a particular trait in your children. So actually choosing what genes you want and what versions of the genes you want to be present in your children. I mean, the best way to design your baby is to choose your partner wisely, I think,
yes,
starting off. But at the moment, there is technology called pre-implantation genetic diagnosis.
Yes.
So if you've got a particular very severe condition in your family and it's indicated medically, you can actually have in vitro fertilization done, so-called test tube babies or test tube embryos made, several embryos made, and then you can actually select for the one that doesn't contain the particular mutation, so that your child is then at zero risk of developing the condition that you know runs in your family.
And in terms of stem cells usually controversial. You divide, that's your area of interest.
Yeah, absolutely. I mean, what we do in our department, or what I'm busy working on, is really using stem cells as a model to understand how cells die. The big controversy is, of course, embryonic stem cells and the idea of when life begins and the termination of life in order to generate stem cell lines. But the cells that we work on are actually cells that we obtain from patients' skin, so usually just a biopsy in the arm, and we actually turn them into stem cells. And once we have a source of stem cells, we can use them to grow any other cell in the body. But we're using that purely for research at the moment. There's no transplantation happening.
Nothing happening yet. Now, in terms of neurology, your field, what are the exciting developments?
Well, there's been a lot of work regarding stem cells in neurodegeneration. So looking at even conditions like Parkinson's disease, the implantation of stem cells to see whether that could make a difference, for example, in the cells that produce dopamine, which is a neurotransmitter in the brain, essential for movement and smooth, energized movement. And these cells, the stem cells, what we are obviously hoping will happen is that these stem cells would take on the function of the normal cells that produce dopamine. And, a lot of research still needs to be done in these fields. There are anecdotal reports that are out, but not conclusive enough yet. And the same with the cardiac system in terms of coronary artery disease.
It's incredibly exciting. I mean, for me, the potential. The more you understand about genetics, the more potential there is to cure disease. You could replicate the process. There's controversies about growing organs. How far are we away from doing things like that?
In terms of growing organs, I think we're probably still quite a long way away. Although there are advances being made, so 3D culture systems and 3D printing are allowing us to grow in petri dishes things that start to resemble organs. We're not yet at the stage where we're going to be harvesting them and actually doing transplants.
And in terms of nutrition? Naazneen?
I think, in terms of the nutrigenomics, it's also still an evolving field.
Yes.
Nutrition has a half-life of 3 months. Every 3 months there's something different, something new. So the idea is that there's still need for sustained research, and as that information becomes more evident and sound, we can share that.
Any final thoughts on the future of what this field of genetics holds?
I think the big advance is going to come in the area called pharmacogenomics. So that's really understanding your own genetic makeup and how it interacts with the drugs that you take and how your body then responds, processes those drugs and develops potential side effects. The big question for us, of course, is how that occurs in African populations, since they've traditionally not been studied very closely. And so that's a big motivating factor for the continued research at UCT's Division of Human Genetics, is really to look at populations in under-resourced areas and look at how we can empower them to take full advantage of the next kind of genomic revolution.
Thank you so much to our guests for joining us for this very, very interesting and controversial discussion.